Can mantle plumes cause new subduction zones to form? Hi, I'm Allie Sealander, and I'm here to help explain how mantle plumes can cause a new subduction zone to form. In another video, we showed how a new subduction zone could form when dense oceanic lithosphere sinks adjacent to a major lithospheric weakness, such as a transform fault or fracture zone. In this video, we show another style of spontaneous subduction initiation around the margins of a large mantle plume head. This is called Plume-induced Subduction Initiation, or PC for short. How does this happen? Mantle plumes are hot and buoyant, but solid masses that occasionally rise from deep in the Earth's mantle. They rise because they are less dense than the mantle they rise through. Because the surrounding mantle is very viscous and impedes the rise of the plume material, a new plume will grow a mushroom-shaped region at its top, called a plume head. This will grow as the new plume rises and can eventually become many hundreds of kilometers across. The rising plume head will begin to melt due to lowering pressure as the plume approaches the base of the lithospheric plate, and these magmas will erupt at the surface to form a large igneous province. The hot plume head and the magmas that rise from it will also weaken the lithosphere above the plume head. If the plume head is large enough and hot enough, surrounding intact lithosphere may collapse to form a subduction zone. This is what geoscientists Scott Whattam and Baes think happened 100 million years ago to form the subduction zones around the Caribbean plate. Numerical experiments are very useful for showing how PC works. A scientific team led by Professor Gerya developed such a model, using reasonable physical properties for crust, lithosphere, asthenosphere, mantle plume, and partially molten mantle. Notice that we're not showing the plume itself, just the overlying oceanic lithosphere. Once the mantle plume head reaches the base of the overlying lithosphere, the plume head begins to melt, and these melts rise into the overlying lithosphere, weakening it. A ring of surrounding lithosphere begins to sink, and eventually one side begins to sink faster than the rest. Part of the sinking lithosphere begins to tear, and after a few million years, the part of the sunken lithosphere that is still attached to the overriding plate evolves into a new subduction zone. That's how Whattam and Stern think the Caribbean subduction zones formed. Let's take a look at that sequence again. We hope you've enjoyed learning about how mantle plumes can cause new subduction zones to form.